So this is me, and I'm going to talk about molding and casting. This is where we are, and there's only 2 more to go before the end of the day. And I'm not going to read this whole thing. It's in your booklet. I presume that you've read it. But I'm going to kind of, what does this mean? What are we saying and why? And so I thought I'd break it down into parts. And the first part is you're familiar with ethical implications. What do we mean? How can molding and casting have ethical implications? Data. We've talked about fossils as data a lot. How can the data be lost or obscured? So what's an ethical implication? The first one is whenever you mold and cast something, you are going to make changes to the specimen that are irreversible. And researchers don't always know that. You could be precluding some future research that we don't even know exists yet. So you need to make sure that the researcher knows about this and that that's recorded. There's all kinds of specimens that will be, substances that will be in contact with the specimen because of molding and casting. You can add adhesives, filling materials, and rubbers, and we don't know what effects those have. This is an unconsolidated specimen that was stained with silicone oils, and that's a permanent change to the specimen. So what's another ethical implication? You're going to mold a specimen that belongs to another institution. This happens all the time. We borrow a specimen and we want to mold and cast it before we return it. But do we have permission to do that from the institution? Usually there's an agreement that spells out how many casts you're going to make, where those casts are going to go, because you may send several back to the original institution if they don't have the capability of making molds and casts. Where are the molds going to be permanently housed? These are all important considerations, and I get the researchers saying, oh yeah, so-and-so told me I could do this. I'm like, no, I need it in writing. No, I really need it in writing. An email is fine, but you need to have something permanently on record that says you have permission to do this and what the rules are according to your agreement. So what's another one? A lot of times you're making a mold and cast for something for display. So is there a difference between a research cast and a display mold, or a display mold and a research mold? Well, there's really no danger. There's no difference in terms of danger to the specimen. It's always a danger to the specimen when you mold something. So by my lights, you should always make a research quality mold. And that means the finest mold you can make, capturing as much detail as you can. And then what I do is I make one master cast, which I try to make as perfect as possible, that stays with the mold. So hopefully if you ever had to remold it, you could remold it from the master cast and not from the specimen. Every time you remold a specimen, there's a danger of breakage. Then I might make however many research casts are specified by the agreement, usually 1 or 2, sometimes 5, before I make one that's going to be a cast to be painted for display. Because every time you make another cast, the mold diminishes in quality a little bit, so you want the first cast to be the best. So what's another one? This is how data is obscured or lost or destroyed. This is a cast that was made for display, but we don't really have other casts of this specimen. And that looks really nice, right? It's a nice lower jaw. That's what the specimen looks like. And it's really delicate. You don't want to be remolding that. And there's no delineation in that cast as to where the real specimen ends and the reconstruction begins. So this is another one where it's very carefully delineated. So a research cast particularly, is going to be all the same color. So you have to physically define where the edges of the bone are and where the edges of the fill or the reconstruction are. So how else? So I think of specimens as data or information. They're the primary paleontological research information. So data can be lost, obscured by filling materials, by adhesives. It can be destroyed by your mold design. If the specimen is broken, that's data that's lost. So in this case, the data was lost by filling, and that was a choice I made because it's a very delicate specimen. And we decided to fill the specimen rather than risk damage. And that's just a choice sometimes you have to make. Or you might have to design your mold in such a way that it captures all that data. You know, my notes are actually somewhere hidden on this page. So another way that mold data is lost or obscured is if the specimen you're asked to mold is covered already with layers of shellac. This is an AMNH specimen that I was asked to mold, and it was many years old and covered with shellac. So we spent more time actually removing all the shellac to get down to the basic morphological information than we did actually molding it. But that is not informative. That is not morphology. Oops, wrong, go back. This is not morphology, that's glue. So if you cover your specimen with a thick layer of consolidant, you're doing the same thing. You're molding a layer of plastic, and you're not molding morphology. So it's you really need to be aware of what you're applying to the specimen and what it's doing to the information that you're capturing in the mold. So the next part, you're able to decide whether you can even mold this fossil, what kind of mold you have to put on it to make a successful mold. Yeah. So are these suitable for molding? This is a tiny Jurassic mammal jaw. This is actually a brain case, and the brain goes all the way through. So can you mold that section? This is a tiny little reptile jaw, Permian reptile jaw. These have all been successfully molded. But it's a decision of what kind of mold you're going to make and what kind of rubbers you're going to use. Your choices of materials all impact on whether you can successfully mold these kind of specimens. Next. So again, that's the kind of mold you're going to choose. You can make a one-piece poured mold where you have a solid piece of rubber. And that's the simplest mold. How many people know how to make simple molds? Yeah, almost everybody. How many people know how to make two-part molds? Good. How many people know how to make a layered mold where you've got two or more parts? Yeah, that's fewer. And the more complex the mold gets, the more experience it takes to learn how to make those molds. So mold design is also driven by what you're going to use to cast it in. If you're making a solid polyurethane cast, you design your mold with things called sprues or pour spouts because you're going to pour the rubber into the mold. That has issues in design because if you've got, say, the back of a lower jaw and you're pouring rubber in, it might stop about here and your specimen's kind of here. So you end up with great gapping holes. So you have to create air vents that allow the rubber or the casting material to flow back out. Where are your seam lines going to be? How are you going to best protect the specimen from the stresses of basically demolding. Demolding is the most stressful part of molding, when you're pulling the mold off. So this is all design decisions, like how are you going to design the mold so that it's safe for the specimen. And this is, I don't generally make solid casts, and I don't make polyurethane casts. So my molds are designed without pour spouts or without sprues. This is a very delicate specimen prepared by Alan Zedinak and molded by Vicky Yarborough. It's paper thin, three-dimensional, and we decided to make a very thin-walled, layered mold that could be pulled off without damage to the specimen. So the next part is gap fillers. So you're going to always have to fill the gaps in a specimen so that the rubber doesn't infiltrate your specimen. So you might have a whole selection of different kinds of materials. You're going to have separators, and there's a bazillion kinds of molding compounds and casting compounds. And I use the ones I use because I'm familiar with them and I've used them for a long time and I like them. Just because I use them doesn't mean they're the best or that they'll work for every situation. So this is an example of a gap filler question. We needed to mold this specimen in situ, right? All those bones are broken. They came that way. We got them out of the ground that way. But all those need to be filled with something, because otherwise when you put the rubber on, silicone rubber is amazing. It goes everywhere. You'd think it's really thick and it looks like it's not going to go anywhere, but it gets in there. So if I didn't fill all those holes, I would pull the mold off and all those pieces would come out and they would probably break further. So you have to choose what kind of materials you're going to put on there. And the other thing is, anything you put on, you have to be able to take off. So if I put, say, epoxy putty in between all those, I couldn't take it off. So I couldn't, they're all askew, right? So I couldn't remove it. So you want to be aware that you want to be able to put stuff on. It's like wax on, wax off. You have to put stuff on, but you have to be able to take it off without damage to the specimen. So this was my choice for this one, because there was still a lot of the original matrix, which wasn't informative. The green is Carbo Wax, polyethylene glycol, and then I just rolled out plastilina clay to cover all the matrix and just butted that up very carefully against the specimen. But here are just a few of the materials that you can use for fillers. You can use, of course, adhesives and consolidants as barrier layers to prevent, say, your Carbo Wax from infiltrating the specimen, or to prevent the silicone rubber from changing the color of your specimen. You can add bulking agents, so like Cabosil or even ground up matrix. You can add as a fill if you're filling areas. You can use Carbo Wax. Carbo Wax, everybody's familiar with Carbo Wax, right? It's water soluble. I don't like to use it as water soluble because most specimens are water soluble as well. So I apply it molten. It's the blob on and sculpt back method. Or I also use low molecular weight Carbo Wax, and I'll get to that in a minute. You can use plastilina, like clean clay or Van Aken clay. It's a little bit difficult to actually remove completely from the specimen, and I can't tell you how many specimens are in our collection that have clay on them or rubber on them from old molding attempts. that people just don't completely remove. And plastilina is made with oil. The green kind that you see as a sculpting clay should never be anywhere near a specimen because it's got, well, I heard it had animal fats, but it's definitely full of sulfur. Sulfur reacts mostly with any kind of rubber, inhibits the rubber, and it soaks into the specimen and can discolor it. Paper fills, you can use paper and then use paper and cover it with Carbo Wax. You can just use it as a barrier layer if it's thin enough. Cyclododecane seems like it's having a new problem with getting it, but I haven't really had it work as a molding fill because it evaporates faster than I get around to doing things. It sublimates faster. So these are also another table of gap fillers and separators and some of the ways that they can be removed, what happens if you don't completely remove them. If you don't completely remove the Carbo Wax, it's going to interfere with further adhesion because it's going to be a resist. This is Carbo Wax, the famous Carbo Wax. I like to add a bit of color. This is just powdered pigment that I add because I've molded small mammal teeth and found out later that there was a blob of wax that I didn't remove, and because it was clear, I couldn't see it until it was in the cast, and there was a blob in the cast. So now I make it green. These are just a few of the kinds of Carbo Wax. So it's called Polyethylene Glycol, which is the PEG, right? And then this number is an indicator of the molecular weight. So 200 is a liquid. Polyethylene glycol is in a lot of like hand lotions. It's in a lot of products. This one, 8,000, is very, very solid and very dense and hard to move. There might be a case where you'd want to use that. I've been using a combination of 1,000 and 3350, and that almost makes a paste that I can warm in my fingers and smooth in, and I quite like that. It's a lot easier to remove. I don't know why the combination works, but most people use 3350. It's also Miralax, in case you wanted to know.
I'll be talking about that tomorrow.
Okay. So this is how I would fill a tissue paper fill. So you don't want to have a solid mass of Carbo Wax filling a large area. So you would wad in, say, tissue paper or something, and then cover it with something that you can sculpt. So it's blobbed on liquid, and then sculpted back to just below the surface of the bone so that there's this really clear physical delineation between the bone and the filler. Because again, the cast is going to be solid, right? So you have to be able to see a physical delineation. This is just a piece of paper. It's right in here. And it's just tacked in with Paraloid B72, a little bit of green Carbo Wax around the edges to fill any gaps. And it was really quick and easy without having to do a lot of stressful otherwise filling. This one is a very porous bone. So you could fill this with, say, Carbo Wax. But how would you get it out without damage to the bone? And in this case, I just chose to make a barrier layer of a really thin paper. Because you're not really losing any data, right? The data is already lost. It's already eroded away. So this is a little moralizing. You want to think several steps ahead of where you are when you're molding. If you're applying something, you're going to have to remove it. When you design a mold, you have to think about casting. You have to think about demolding, but you also have to think about how am I going to cast this. So you have to be, thinking ahead, a little critical thinking there. I should have put the sign down at the bottom. And I don't know why I put this one in here, except these are my favorite tools. And so this in the back is actually the mixed Carbo Wax. And this was a very complicated specimen to fill a lot of holes. And we could use that as a paste and just kind of scrub it in with your thumb, take a little ethanol to clean it off the surface so it's just below the surface. And it was really easy to remove. This tool right here it's the Hugh Freedy number 11 PFI, plastic filling instrument. And it's a great mold making tool. Hugh Freedy, H-U-F-R-E-I-D-Y, PFI, number 11.
So the Vinco dental tool supply sells that.
So you get all your molds made, and you have to decide what are you going to use to make them with. There's silicone rubbers, polyurethane rubbers, latex has place in mold making, especially for really large objects. Are you going to use a platinum cure or a tin cure silicone? They have different properties. They work different for different kinds of mold making. I don't believe that a platinum cure mold material will really work that well for a layered mold unless you can stay on top of it, because it doesn't adhere well to itself once it's completely set. So you get delamination. If you want to stay up all night and work straight through, it probably would work. Casting materials, you're going to have to choose what kind of casting materials you're going to use, and that depends on your specimen, and it depends on your end product and what do you desire. And then you probably need to know, why are you selecting one rather than another? And a lot of that is just experience, or talking to people who've had more experience. I haven't really found much literature about molding and casting. I think the most information I find is on people who do model making or mask making for special effects interest. You know, they do a lot of products. So you can have harder or softer durometer rubbers. So you can have the same silicone and add a different catalyst, and it will be softer. And there's specimens where, if it's really delicate, you could even do a poured mold if you use a softer rubber. Just, there's a lot you can control. So, getting to the end, you're trained in the management of potential health risks. Management? Health risks? What do you mean? So I'm going to say I think almost all casting materials are toxic. And the ones that I found that aren't toxic don't work very well. So you have to learn how to manage the associated health risks. You should not do it just in your lab in the open, even though it probably says that you can. There's long-term implications and long-term exposure. And just because it doesn't smell bad doesn't mean it's not bad for you. Polyurethanes are just full of isocyanates. And even if it's set and you think it's not smelling anymore, if you go to grind the edges of it, you're still releasing bad chemicals. So they're MSDS. I think they're called SDS now. For every product, and if you don't get it with your product when you purchase it, you need to call the manufacturer and get it, because they're full of information. And they should be on hand in your lab. Our institution makes us have them in our lab. They say, oh, they're available online, but I like to have them in the lab. There's a lot you can learn. So this is a sample one. what does it tell me? Well, it starts with telling me the name of the product, the emergency contact information, hazard statements. So it talks about prevention of exposure, storage of the product, disposal of the product. What are the ingredients? And this one says it's proprietary. So, I mean, I know part of the ingredients, but they're probably proprietary ingredients that I don't know about. First aid measures, and all of this. And one of the most important ones is exposure controls and personal protection. And it will tell you, you know, what kind of protection you need from this, how many parts per million will kill you. So this is Alana, and I had her dress up in every piece of PPE that we owned practically. But I always work in a fume hood when I'm using any casting material. Some of them will say use with proper ventilation, meaning you can use it in an open room or outside. You're still ingesting some. Anything that's not really small, you probably should be wearing a respirator as well. In this case, she's wearing goggles to protect her eyes from splashes. The hearing protection is probably unnecessary in this case. Lab coats, long pants, long sleeves, closed-toe shoes, nitrile gloves, not latex gloves, because latex gloves don't protect you from solvents. And here it says all those same things that I just said. Dust masks if you're using plaster. Should never really ingest particles. So that was pretty much it. And then this is just my little list of Marilyn's rules for mold making. So I don't think that really made it into the competencies, but the big one, I think, is the specimen should always be in as good or better condition than when you started. And that was pretty good.